Good morning everyone, myself Nashika Sharma. Welcome you all to Keras, the ultimate Lego framework of machine learning. Let's start today's event with positive mindset and strive to make the best of everyone, every moment. Now I want to introduce our speakers for the day. Mr. Aritra, MLE at PyMH Search, contractor at Keras, GDE in ML. And our next speaker is Mr. Ritwik, MLE at PyImage Search and GDE in ML. Sir,
Yeah, go
Hello
ahead, Ritwik.
everyone. Hello everyone. It's a pleasure to be here. We have seen up and new coming announcements from TFUG Duke for a long time. And when we got the invitation, we were obviously honored to be here. So thank you, Karthike. So I'm not going to waste much time and I'm going to share my screen. Let me see if this works. You can probably give me a thumbs up when you see it. Is the screen visible? Are
Yep.
you able to see the beautiful slides? Okay, good. So what we're going to talk about today is obviously as mentioned by the host, Keras, the Lego framework of machine learning, and our idea for this talk is to leave you with a basic understanding of what Keras is and how you can leverage it, why you should be worried about leveraging Keras in today's machine learning landscape, and what it provides to you as both a beginner and an advanced practitioner. So, just for the sake of putting this on the slide, both of us are GD in ML, both of us work at PyMed Search as machine learning engineers, and one of the great passion that we both share is deep learning education and making topics that we love and we understand in machine learning accessible and available to everyone. So this talk is a part of that same endeavor. And as I was saying, the today's talk is broadly going to be divided into two categories. First category, which is a brief overview of Keras, will be taken up by me. And then there's the second category, which is the future of Keras, or how Keras will continue to serve you and all of us as ML practitioners in the future, will be taken up by Aritra. And in the end, what our hope is to leave you with a coherent story of what Keras is and how it is going to evolve to serve you better as machine learning engineers and machine learning practitioners. So with that, let's dive into the overview. So I'm hoping that people in here have heard about deep learning and are somewhat familiar about deep learning. So deep learning, in a sense, is just matrix manipulation. We can say that it's just matrix manipulation. We are mostly always trying to fit this formula that you see on the screen. And if you have started your journey, with understanding the fundamentals of deep learning, then this formula should be known to you. Otherwise, it's pretty straightforward to understand as well. It's about approximating y as a function of x with some weights and biases. And since life is not always linear, there's a little bit of wiggle room in the form of sigma, the non-linearity, which allows you to bend your data or your weights and biases in a way that it fits the data. So transforming this into code should be pretty straightforward as well. And if you don't understand all the all the syntax or all the bits and pieces of the code, that's fine. It's just syntax, and it is easily searchable on the internet. What I want to take from this slide is whether you can relate the formula on the left with the last line of the code on the right. And if you can, well, that means that you are able to understand that transforming this formula into code is actually pretty straightforward, even in TensorFlow or Keras or whatever framework you are working with. And that's just one pass. Like you have data, and you define your weights and biases, and you sort of try to fit that onto your data. But let's be honest, nothing good is guessed in the first pass, so we need to update the weights and biases after every pass, so that your equation, or your y is slowly kind of fits the data. So how do we do that? Well, we can calculate the loss, which stands for how far away from our target goal we are. So we express the update in terms of delta loss to delta weights. And in calculus terms, you can think of this like how nearer or farther you are from your target, which is zero loss, and how will you like how much how much would you travel nearer to your loss if you travel a minuscule amount in your car, which is actually your weights. So if you change delta weights by a small minuscule amount, how much nearer are you to your zero loss target? And calculating derivatives is fun. While it's mostly fun, but we do need to automate this process, because like there's going to be millions of parameters, and a lots of weights and biases. So a lots of delta loss by delta weights. And in comes something with something called TF gradient tape. The actual documentation is linked, and you will receive the link to the slides once the talk is over, so you can check over the documentation. But in a nutshell, I just want you to imagine for a second that you are in a skating park with lots of railings. Some are steep and some are not so much. And the steepness of the railings is what you call your gradient in machine learning terms. This is the gradient or delta loss by delta weights that we saw in the previous slide. Gradient tape actually allows you to lay down a tape along the railings and measure the steepness of the gradient. And just like in skating park has many railings, your machine learning model will have many variables. Some will be important in terms of tracking the loss, and some not so much. So you can lay down the tape and measure the steepness or gradient of whichever variable you want to measure. So that's in a nutshell what TF gradient tape does. And for those really interested, we have a dedicated tutorial on automatic differentiation on PyMessage. We discuss the actual mathematics behind differentiation and automatic differentiation. Also study it through the lens of building a custom package for gradient calculation. This makes you build the intuition behind automatic differentiation from scratch, rather than using existing APIs from TensorFlow like TF.gradient tape. If you need a quick ML project for your final year, you can probably skip this. If you really want to learn the field of machine learning, dive deep into the mathematics so that you can really understand and contribute to the field even 5 to 10 years from now, we highly recommend reading through the automatic differentiation tutorials. It doesn't have to be ours, but you can start here. If you want to access it, or if you want to access it later on, just take a screenshot, or scan it from the recording, whatever you want to do. But this is this is a QR code that will take you to that tutorial series. Now back to TF.gradient tape. What we have is a mechanism to record the value of automatic differentiation. So we have lots of weights and biases for our y equals mx plus c, but an expanded format of that formula. And what we want to do is find the loss, or find the delta change to our predicted value from our target value with respect to the weights. and we have a way to automatically measure that, and that way automatically record that, uh, and keep doing that over many passes, and that way is tf dot gradient. It is our method mechanism to record the value of automatic differentiation. But what we now need, we have got a mechanism to record the value of automatic differentiation for the delta change in our loss with respect to the change in our weights. And all we somehow need to do right now is to take this mechanism that does calculus for us automatically, and transform it so that it is somehow able to classify images, segment depth, generate artwork, generate 3D models. So how do we do that? How do we take this small bit, this small part that just a second, this small part that's um, that is able to do automatic differentiation, and then build an entire system of useful machine learning applications around it. Well, to understand that, we have to come a little bit closer to Keras. So we need blocks, loads and loads of building blocks, and Keras is our answer here. So really, in very basic terms, I want you to imagine that your entire machine learning model is a castle you're building in Lego. So I'm sure every one of us have heard of Lego blocks. They are small, cute blocks that you can attach on top of each other and build really cool structures. We used to think of them like we used to be crazy about them back in our days. I don't know so much like for you guys, but so what I'm trying to do here through the rest of the slides is draw a parallel between those blocks and machine learning APIs. And you might think that it's really childish, but once you really understand the full extent of what Keras is able to provide you with, you will understand the analogy a little better, and you really start to see the parallels. So again, imagine your entire machine learning model is a castle you're building in Lego, and Keras gives you the building blocks, and those building blocks are consistent and simple APIs that Keras provides. So if you need a door of the castle, in machine learning terms, a data loader, Keras will have the provisions for that. And if you need a very general purpose, small Lego block that you want to reuse for something else, Keras gives you great APIs like sequential as well. And don't worry if these are just jargons to you right now. We will sort of cover them as we go through the talk. And this is like a small sneak peek into what Keras is actually going to do for you. It is the mission statement of Keras is to give an unfair advantage to any developer looking to ship machine learning powered apps. And the idea is you don't need to study hours of theory, or you don't need to code up your entire training pipeline or create your entire machine learning architecture from scratch. You have sort of reusable small cool elements that you can use inside of Keras, but you also have great APIs that will let you do really complex stuff if you want to. So Keras focuses on debugging speed, code elegance, and I can really vouch for this, conciseness, maintainability, and deployability. When you choose Keras, your code base is smaller. It is much smaller. We have with us Aritra, who will later on talk about a Keras project that he worked with, and that's just like some 420,000 something lines of code. Yeah, so that it is readable. That's one of the things that we pride ourselves on, that your code should be entirely readable. It should be for lack of a better word, written in English and sometimes syntax, and it should be easier to iterate on. So someone else who comes in to read your code should not be thinking about life-ending decisions because of that. Your models generally run faster due to XLA compilation, and XLA compilation is like your Lego cars, but with an engine of their own. So that's a really small sneak peek into what Keras can do for you. But how it does that for you is something that we are going to see right now. So we kind of now understand that Keras is actually really well positioned to be the Lego blocks we need to build this whole system around TF dot gradient tape. And these, like, we understand that these Lego blocks can be something that we can that we can have with Keras. But what exactly are those blocks, and what are those blocks called? And show us some code, because we are developers and we are not here for just talk. So just for the sake of reading them out loud from the screen, these are the individual blocks. They are your necessary imports, your data pipeline, model construction, model compilation, model training, and model inference. And if someone of you is really new into machine learning, or new into this whole idea of building a machine learning architecture, if you can take one thing from today's talk, what I would like you to take is this slide. Take a screenshot, take a picture, put it as your phone wallpaper. But this is this is something this is your Bible. If you are creating a machine learning project, you probably will need to follow these steps in this order, and expand on these steps. And you might think, well, that is really, really not creative, because you're laying down a couple of rules and then saying that you need to follow this. But what you can do inside of these steps is really your own choice and your own creativity. So back to the topics. This line really does not need much explanations. You need your imports, you need TensorFlow, and you need Keras. Do note that this is the original version of Keras and not something called Keras Core. For that, right now you do need a different type of import that Aritra will be talking about. Next is the data loader. So back to our Lego analogy. Whatever is coming through the Lego door of your Lego castle is Lego small items or human beings. They are shuffled, they are mixed, they are neatly packed into groups. This is called batching, and a specific operation is applied to them through the map function. And all of this might be just syntax jargon to you at this moment, but what you need to remember is that these operations are done, like shuffle, batch, and map is done, so that the model learns these items and really learns them. It does not memorize the order in which they come in, or the features, like the individual unique features that they have, so that when the next time new items come through the Lego door of your Lego castle, it is able to combat them or understand them. And in machine learning terms, this is equivalent to when new data is shown to the model. It should generalize to new data as well. So next is the really meaty part. So think of sequential as the foundation or base plate of your Lego blocks. It's the starting point. It signifies that you will be stacking layers in a linear sequence on top of each other without any complex connections or branching. And if you're a student of deep learning, or if you are even a student of mathematics, you will understand that you can have complex structures, but there can be side structures that branch off from them. So this signifies to the compiler, or to the to the machine, that you will be stacking layers in a linear sequence on top of each other without any complex connections or branching. You are, of course, empowered to do that if you need it. The dense layer is like a single layer of closely packed Lego blocks, where each Lego block is connected to every other block. So the small heads on top of the Lego blocks are connected to the next Lego block. And what this means in machine learning terms is, if you have seen a neural network, all of those nodes of the neural network are then connected to all of the nodes of the next neural network, and so on and so forth. So in neural network terms, our dense layer is a fully connected layer where every neuron is connected to every neuron in the previous or next layer. And that's just really it. And when you understand intuitively that, okay, now I need to just pass the data and make it smaller, but not lose any important information, but rather make the features smaller, you will understand, okay, now is the time I probably need to give in a dense, versus when you need to do something else and you need a different structure, you'll use a different API. So it enables you to do things in your own way, but it also sort of lays a guideline for you so that you are able to not lose your way and bang your head on the wall. So finally, you compile the model or start assembling your Lego blocks. You use your required optimizer, and your optimizer is the ringmaster who actually tells the gradient loss to go down. Without it your car or your weights will continue to go hitherto without actually going to the target. I'm sure we have all been there in different contexts. And you use your loss function and define the metrics that you need, and these metrics can be your loss function, your accuracy, whatever it is that you need to track or you need to understand in humanly understandable terms that your model is getting better or worse. As the pieces are compiled, your model is finally ready for training. So your Lego castle is done, but it's not perfect yet. Like, it needs to be battle tested against outsiders. And as it is battle tested against outsiders, you repair and update patches to make the model stronger. So no dents are made. This is the machine learning equivalent of your loss going down and you updating the weights so that your model becomes more robust over time. And finally, we are at the last stage of your entire machine learning architecture slash Lego castle pipeline. You also want to see how the model does on unseen data. So you can predict output using the model.predict function. And after all, what's the point of having a Lego castle if you can't show it off? So with that, I'm sorry I went to this slide. I wasn't supposed to show it, but with that, I'll hand it over to Aritra, who will probably talk to you about some other tools of automatic differentiation and how they work. So Aritra, over to you.
Right. Thanks for the great introduction about Keras and how we intuitively understand Keras, and also what deep learning is, how to update the variables that are weights and biases. I'm going to share my screen first and then going to blabber about it. Go live. Let me know if my screen is visible. Right. So yeah, here we are. You were not supposed to show the slide, but here we are again. Right. And before I go into this slide, I just wanted to let you all know some basic pointers that I'm going to keep in mind while I show my slides, which is I don't want you all to just keep your questions to yourself. We will, at the end of the talk, have a little Q&A wherein we are going to take in questions from you, be the people who are internal to TFUG Durg, also people at the audience. So please let us know what your questions are. And I'm also going to do a little recap of what Ritwik did in basic pointers. So the first thing is deep learning. We consider deep learning to be nothing but matrix manipulation. So the inputs can be an image, can be audio, can be text. Everything is a matrix of numbers. And those are manipulated in such a way that our model, which is again a matrix of numbers, can model this data distribution, right? And these models that are our neural networks or whatever we call it, MLPs, VITs, any artificial neural network that comes to your mind, are nothing but a bunch of knobs, tunable knobs. The tunable knobs are going to get updated on each iteration. So these are the core foundational ideas that you should have while you are working in the field of deep learning. Now, the problem with TensorFlow or maybe any numerical library, let's not say it as a problem. Let's just say the nuances of TensorFlow, JAX, PyTorch, NumPy are that these are all numerical libraries in itself, and these numerical libraries help you do or achieve those data manipulations quite nicely, right? So you have inputs, matrices of numbers, you have weights and biases, matrices of numbers, you manipulate them with a numerical library because these are essentially numbers. Now, the numerical libraries are of various kinds. As mentioned, TensorFlow is one, NumPy is another, Torch is another, JAX is another. So, just off the dome, I could spit out like 4 numerical libraries that anybody can lay their hands on. Now, what Ritwik also mentioned is that we are just not talking about the numerical libraries or the numbers or matrices of numbers. We also need to understand how we update those numbers on each iteration, that is training of your neural network. To do that, he mentioned calculus and gradients. So with gradients, you understand how sensitive my weights are to the loss. And with that sensitivity, you are going to update that with the optimizer you have in mind, right? To do that, the core foundation is calculus or gradients. And these numerical libraries, that is TensorFlow, Torch, JAX, these all come with their own automatic differentiation engine, right? These engines help TensorFlow, PyTorch, and JAX to compute those gradients automatically. Hence, automatic differentiation is nothing but gradients. So, automatic differentiation. Now, come to think of it, Keras previously had a backend called TensorFlow. So, tf.keras is what we used to import in our Colab notebooks and our scripts and whatnot. But with the latest update in the Keras team is that we have something called Keras Core. What Keras Core does is that it harnesses all of these automatic differentiation numerical libraries, which are TensorFlow, PyTorch, and JAX, all at once, so that you can use all these goodies that are baked inside of TensorFlow, maybe PyTorch, maybe JAX, and use it with a user interface called Keras. So think about all these numerical libraries as backends and Keras as your one-stop user interface that can help you navigate through these different backends. So you don't need to, if you are a PyTorch first person, you don't need to change anything. You can just use Keras Core and use the backend. If you're a JAX first person, same. And if you're a TensorFlow first person, you basically have to change nothing in your code base and everything works off the bat. So about did my stream get paused for some reason?
Oh, it's still going on.
Oh, okay, cool.
It's still going on.
Right.
Yeah.
So this was what I was coming to. So what is Keras Core? It's a full rewrite of Keras. So while you talk about Keras, is that Keras was deeply integrated with TensorFlow, and TensorFlow has these two versions. One is TF2, which is something which we like, and one is TF1, which is something which we dread. Now, Keras itself as a user interface and Keras Core maybe as a user interface is decoupled from all the TF1 jargons, right? And that basically brings down the lines of code from maybe 140 to 43K, right? And all of this was TF1 debt that we removed. And if you go to the Keras Core library, which is github/Keras team/Keras Core, you can see that the code is really intuitive. You can understand what the Keras Core backend does, and also help you understand what Keras as its own core has as its philosophy. It supports multiple backends, so JAX, TensorFlow, PyTorch, everything has been covered. NumPy is something which is very close to me because that was something which I worked on solely. So the NumPy backend was created by me. And it is a backend which is inference only. So due to the fact that NumPy does not have its own automatic differentiation engine, you cannot train your NumPy backend, but you can always load the weights and biases of a model into your NumPy code, and it works seamlessly for inference. So maybe you want to debug something in NumPy, which is always eager. You don't have graphs and stuff. If you want to debug your code, if you want to debug your model, NumPy is your go-to. It's a drop-in replacement for tf.keras if you're using TensorFlow, and it works seamlessly with Keras NLP and Keras CV. So these are sibling repositories inside of Keras ecosystem. Keras CV, as the name suggests, it's a computer vision first repository. So if you are a computer vision engineer, you want maybe YOLO V8, you want ResNets, you want efficient nets, you want a vision transformer, everything is baked inside of Keras CV. If you're an NLP guy or anybody who is interested in natural language processing, so all the hype around large language models, everything is covered in Keras NLP, right? Going to what is Keras Core, and at PyMetSearch we have covered what is Keras Core, and this is something which the internal team at Keras also uses, and I know this because I've been working with them. They found this very intuitive. They have also found it as a guide for anybody who wants to come to Keras Core, as in jump into the project to understand what it is. So feel free to take a screenshot, go to the link in the QR and read what Keras Core is. I can guarantee that Keras Core is one of those inventions, or maybe a repository that was invented in order to cut down the fragmentation of everything, or as in the numerical libraries, which is really intuitive and something which you can just jump in and work off the bat. So that's crazy. Now, talking about the rewrite of Keras, this is a tweet from the creator himself, as in the creator of Keras himself, Francois Chollet. He says that the lines of code, LOC, got down from 135k lines of code to 43k lines of code. Just imagine the compression of the code base once you remove TF1. And anybody who likes TensorFlow, please don't go to TF1. Now, multi-backend, if you can, I'm sure the slides will be open sourced once our talk is done. If you can't see the code right now, don't have to worry about it. It's just a sequential model with compilations and model.fit API. The thing about Keras Core is that the entire script is backend agnostic. So you can use your favorite backend, as in TensorFlow, JAX, NumPy, or not NumPy because it's not going to train, or PyTorch. You can just seamlessly switch those backends and run this script, and this script is going to run off the bat. Not a problem. And it's going to train with numerical stability. So that's something which we all focus on. If you find bugs, please feel free to go to our issues at Keras Core and also look into the pull request and issues that are already up, so that you can understand whether the bug has been already resolved or somebody is working on it. So it's in beta stage, so there will be bugs, but it's prone to training with numerical stability as much as possible. So that's good. Drop-in replacement for TensorFlow. So me and Ritwik both work for PyMetSearch, and PyMetSearch is biased towards using Keras and TensorFlow because we have been using that for a long time. And yeah, exactly what Kartikeya said. So it's like the Apple ecosystem. Don't just go back to TF1. And talking about the drop-in replacement of TensorFlow, it basically helps us to knowing where we are at. So we don't have to change our legacy codes, but also if we want to harness something which is quite interesting in maybe JAX or maybe PyTorch, we can just seamlessly switch the backend and it works. And talking about seamless switching, how can I not mention how to do that? So the Legos that are there, and due to the fact that it's a Lego block, and all of the backends are termed as superheroes, and they need to protect their own castles. So TensorFlow is very deployable. It's very complete. It's a very complete ecosystem that we love, and we have been enjoying using that. And TensorFlow, one thing about TensorFlow is that it helps you deploy your models seamlessly with TF Lite, with TensorFlow serving, and whatnot. So if you are going to use Keras with a TensorFlow backend, you just use the os.environment Keras backend environment variable and tag that to TensorFlow. And the script is automatically, or the Python package called Keras core is automatically going to know that, hey, I'm going to run on TensorFlow. And if you run on TensorFlow, you will see that right at the end of the import Keras code, you will see something called using TensorFlow backend. So you already know which backend are you going to use. Now, talking about TensorFlow, how can we forget JAX, which is our current favorite, as in me and Ritwik have been working on JAX for quite some time. We have courses on JAX at PyMethSearch, so please feel free to go to pymethsearch.com and just search JAX in the blog section. The blogs were also reviewed by the internal JAX team, so we are all covered by that. And why we love JAX is because of the XLA compile time speedups that we get. So you can JIT compile it. JIT stands for just in time. You can JIT compile the entire model, and it gives you speedups in maybe 3 to 5 times as to what we could have gotten with TensorFlow. And how can I miss on PyTorch? Because PyTorch is sometimes really revered in the research industry. So think about you doing your final year project, and your academic professor tells you to use PyTorch, and you can tell your academic professor to use Keras and PyTorch as your backend, so that now your entire model is backend agnostic, while you share your code to maybe TensorFlow Hub, PyTorch Hub, or Hugging Face Hub. People can get your model, and they don't need to have that barrier of understanding which backend you have used. If you are comfortable with PyTorch, if your academic professor is comfortable with PyTorch, do so, not a problem. But use Keras as your user interface so that it's agnostic to a point that everyone in the community of DL understands what you have written and can also use it without having to go through that academic barrier. So use any backend you like. We love all the backends. Just use Keras code is what I'm trying to say. And speaking about Keras core, why would you use Keras core? Even with all the things that I have mentioned, Keras core is good at what it does. It is in beta stage, so I'm reiterating again. It has certain bugs that you might be the ones to squash. But if you feel that Keras core is something that you would take up for a spin, I'll also top that with some advantages of Keras core. So the first is its cross-framework data pipelines. So what happens here is that TensorFlow has its own data pipeline called tf.data sets. Torch has its own data loader. NumPy arrays are quite coherent, and also something which I think most of us have been using, understanding what machine learning pipelines are, deep learning pipelines are. So NumPy arrays. Pandas data frames is also something which we like. So if somebody here has been to the website called kaggle.com, you will find a lot of pandas data frames in their as their data set. So pandas data frame is something which we use as well. Py datasets is something new for me. I haven't used it as of yet, but Keras core supports Py datasets as well. So what I'm trying to come to is that, remember how Ritwik talked about the data pipeline? So it's a pipeline where you feed in data, and all the pre-processing happens inside of the pipeline, so that the model is disjoint or does not have to interfere as to what images or what audio or how text is going to feed into the model. everything is taken care of the pipeline. Now the pipelines can be a little tricky for each and every backend, but once you have your pipeline set, you don't have to think about your model if you're using Keras Core, because Keras Core can handle all of these backend pipelines at once. There is no problem doing a maybe torch.vision.compose or maybe tf.data.map. That's not going to be a problem. Talking about data pipelines, we also come to pre-trained models. That is something which we all need. Foundational models, as to say, these are like big models that are trained on big, huge internet scale data. And we as researchers, or we as individual people, cannot like train those huge models, maybe CLIP, maybe Vision Transformer for that matter, with a data set of JFT 200 million. There is also all these LLMs like Llama, Red Pajama, and whatnot. You just can't train all of this. You have to fine tune it, which is you already have a pre-trained model and you fine tune it to a specific task. So all of these pre-trained models that we need for computer vision, for natural language processing, are already and are in works of getting into Keras CV and Keras NLP. And guess what? Keras CV and Keras NLP already work with Keras Core. So think about Keras Core as the big project, and Keras CV and Keras NLP, taking help of Keras Core, are now backend agnostic as well. So all of the pre-trained models out of the box, which are inside of CV and NLP, come in hand and are backend agnostic. So that's going to be cool as well. Progressive disclosure of complexity is something which is a key motto, or the Keras philosophy of Keras. So we are also going to talk about Keras Core's philosophy, which is same as Keras's philosophy, which is progressive disclosure of complexity, which means the framework is not supposed to be simple, but it's not supposed to be complex either. The complexities can be broken down into steps, and a beginner can start with step 1, and an intermediate can start in step 2, an advanced person can start right at the most complex level of the framework. So there is a linear and very helpful disclosure of the complexity of the framework. So you can start with sequential, which is basically a layer, like a list of layers, and you can go to functional, which is a little nuanced, which is again a type of building block. And once you are at a position where you know that, hey, I know a lot of deep learning, I don't need just the layers, I have my own needs for the deep learning model. You feel free to go into maybe tf.keras.layers or kerascore.layers and subclass the layer, subclass the model, subclass the data pipeline, do whatever you feel like. But you basically can. So it's not constrained to just using something which you know and which the Keras team is imposing on you. You can basically extend everything that is probably provided inside of the Keras community, and you can do so elegantly with linear complexity timelines. So that's something which we talk about a lot internally, as well as we try to keep it up and coming. Talking about the final two advantages of Keras Core, one is it's the new stateless API. So I'm not going to talk about much of the stateless API. So see, what happens with JAX is that JAX is not an object-oriented programming paradigm. So it does not support OOPs. It supports what is called stateless. And to support JAX, Keras Core has its new range of stateless APIs. So that it's backend agnostic to JAX, and also distributed training as easy as non-distributed training. So if you have, say, one GPU, you're good to go with Keras Core. If you have multiple GPU, a cluster of GPUs, and you want to scale up your training and you want to compete with maybe OpenAI, who knows? The Keras code's multi-backend and agnostic features lets you use TF.distribute as well as JAX's PMAP, and also Torch's distributed data parallel (DDP), and everything works off the bat. Another little caveat is that you can not only scale up to GPUs, but you can also scale up to TPUs. So we are currently working on that wrapper wherein TPUs get to come into play, and Jax being the king of all of the TPU pods that you can have to do your numerical library computations, you will be able to do it at one time. So that's something which is interesting as well. With that, I come to an end of my talk. I am sure people are going to go to the GitHub repository, and I'm also going to pull that up. So this is Keras code. I'm also going to link that, and if Karthikeya is going to do that, not a problem. Do that, and yeah, that's about it.
Yeah, I can share it in a bit. Just give me a sec. Yeah.
Right, and with that, I think it's time for some questions, Ritwik.
Absolutely. We are here for some time now. So if you have something that you want to pick our brains on, hopefully related to Keras, machine learning and computer vision works as well. So you can talk to us. I'll link the slides in the chat, and maybe they can be posted in the announcements later by Karthikeya or someone who is in charge. Again, we are here. If you want us to talk to want to talk to us about anything, this is it.
Thank you, sir. We hope your guidance will lead us to the closer to our goals. The session was amazing. We got some questions for you from audience, and the questions are as what are the some best practices for improving the performance of deep learning models in Keras?
That's where you want to take that.
Yeah, I will take that. So that's a great question, by the way. So if you want to understand how to improve your performance, you also have to understand there are certain templates that we are providing you to use Keras. That's the first thing. So right after the end of the session, we are going to open source our slides, and remember how Ritwik said about the entire template. So data pipelines, your model construction, optimization steps, and whatnot. Those are the best practices of just training your model. Now, once you train your model and you want it to speed up or maybe be efficient, more efficient, one of my favorite pointers is something which Andre Karpathy, who is presently at OpenAI, was the previous AI head at Tesla. He points out as the first good step is to overfit on one batch of data that you have. That kind of gives you an intuition as to whether your deep learning model is learning. That is the first thing that you have got to understand. It's just not you take up an algorithm and throw it at your data and see what sticks. That is not how it's done. You have to understand that your algorithms are mentally not mentally, it's not sentient. Your algorithms need to have certain checks in order for it to learn better. And also, one thing that me and Ritwik both would agree is that the quality of the data. You have to handpick a lot of things in your data pipelines so that it gets better as you train. So a data pipeline understanding and also any problems in the data pipeline can hamper your entire model workflow. So be very careful about that.
Also, another thing that I want to mention here, just because the topic of efficiency came up, is that with JAX in the picture with Keras code, you can now use JIT functions, and that's something that insanely speeds up your workflow. You will understand it if you read through the documentation or the tutorials shared above. But what it does basically is create it think of it in terms of this: you need to go somewhere new, to a friend's house maybe, and you download the Google Maps beforehand, so you already have the route in your hand. So that's what JIT does, in a nutshell. So yeah, those things work with Keras now, with TensorFlow, with PyTorch also, maybe, if you are doing that. So you are able to leverage all of that to speed up your workflows. I hope that answers your question.
I guess Karan is there to ask some questions. I guess Karan, you can go. Yeah.
Thank you. So great session, Aritra and Ritwik, also great introduction to Keras. So actually, I wanted to ask more towards um, like I've been trying to use large language models on my local system, just like for playing around with them. And like, how do you guys use if you are like using? Do you use any local LLM based apps right now? Like we are not connected to an API.
Yeah, so sorry, I'll take that. The way we do our development is mostly not local. So because like we generally like to preserve our sanity, but not joking. What we our mental process is that we like to do it in a GCP instance or a Google Colab, so that it's shareable and easy. But if you are doing it in your local instance, and if it's being supported, like for example, if you are talking about Keras, Keras Core currently is supported in Apple Silicon, I'm sure in other devices as well. And there are a few pre-trained models in Keras NLP. I think Aritra can correct me if I'm wrong, which you can load off the bat and use. If you're talking about large language models, which are like the models that we see and interact with on an everyday basis, stuff like Bard and ChatGPT, I don't think Keras currently has the provision to load them, load things like that, and run inference on them. But there, I do hear, even being a vision guy, I do hear that there are now ways you can learn Llama 2 or Llama 1 on your system. So curious
Yeah,
to know about that as well.
Rama I have tried recently. So like using the quantization technique, I was able to load it and it ran. But like yeah, I was interested to know like if you guys are doing something in this one. Okay,
No,
awesome. Okay.
thank you, thank you.
Yeah. Thank you, Karan, for your question. And I guess let me move to the audience. Yeah. So yeah, Nishika, you can continue if you have any more questions, because I have one to two questions at the end. Maybe I can ask. But yeah, Nishika can go. Yeah.
No, the questions are fine. Sir, you can ask your questions now.
Sure. So, like I am working with TensorFlow Core and TensorFlow.js, like it's 3 years now. I'm been a part of TensorFlow.js community. So, is there anything maybe you are coming up with TF Lite and TF.js kind of backend kind of thing? Why I'm saying is because while I'm when I'm in GSOC in TensorFlow.js, I basically working on the WebAssembly part of backend of basically of TensorFlow.js. So what I see, and even I work with Task API part, we basically convert the TF Lite model to TF.js and simultaneously quantity part to reverse back that thing. So is there anything Keras core is coming up with maybe related to JS kind of thing of web developers, if I will be more precise around that? Or you can think of TensorFlow.js is one of the best in WebML in that term according to you. So yeah, just your take over that.
Right, I'll take that. About TensorFlow.js, that is something which most of the, how do I say, TensorFlow is loved by people because of the deployability. That's something which is right there on our faces, and nobody can kind of replicate that, right? So what Keras Code in that space is trying to do is unify all of the model implementations into a .keras format, which can then be transformed into a TF Lite, which can then also be transformed into maybe deploying using TensorFlow JS. We don't have anything as of yet and like I can't talk about the entire Keras team. They might have something on their plate, but I haven't been part of anything as of yet in the Keras core team, which talks about uh, something which is very specified to deployability. It's mostly how we unify all the models, all the backends, and also how we use the .keras format, saving format.
Yeah, and apart from that, what your best backend according to you? Like what you prefer if I will say PyTorch. Yeah, I'm not just even though we are TFUGs, even you will go with PyTorch because I talk with many machine learning researchers, I guess a year back, and they are saying if we are researcher, we have to do PyTorch, not TensorFlow. So
Okay.
like, what's your take on that? Yeah, yeah.
That's a controversial question. I'm going to skip that. I like Jax a lot because of the efficiency it provides, and TensorFlow because of the completeness that it provides. I love PyTorch, by the way, but it's just that it's not as efficient as Jax is, and it's not as complete as TensorFlow is. So it somehow kind of falls off the edge. But due to the fact that researchers love it, we have been seeing, like me and Ritwik have been understanding the code bases of a lot of papers, and we find that it's very easy to read and also to debug, because the first thing that a PyTorch user comes to with a TensorFlow user is the eager operations, how TensorFlow uses graphs, and it's kind of not that intuitive once you get into TensorFlow. But once you're coming off from maybe NumPy, you get into PyTorch, you understand everything off the bat. Like, hey, this is similar. This code, I understand it. I can do a print statement inside of the entire forward loop, and I can debug it right off the bat. But that also creates something called as not compilation problems, and you have got to JIT compile the PyTorch implementations on your own, which again TensorFlow does not do it. TensorFlow does it on like hands-on, and it's a default setting. So with that, I might go with Jax because Jax is very efficient. Next comes TensorFlow, next comes PyTorch, but not saying anything against PyTorch.
Yeah. Also, I would like to say something here that the whole philosophy behind Keras Core is to sort of make these kind of discussions redundant,
Right,
and
yeah.
say that if you like PyTorch, we are not asking you to switch. Do your thing. Do PyTorch. Save your model in Keras, inference in Jax, whatever. That's the whole ideology behind this masterstroke. And also one of the things that we would like to point out is that these things happen in cycles, right? When you're saying PyTorch or TensorFlow is preferred by the research community, it's because that has been the standard status quo for like 8-10 research cycles, and we are yet to see the code come out for new rips and for SIGGRAPH, which is later to happen. And we might just see, who knows, a Keras code implementation with all backends. So the next phase of the research cycle is still up for grabs. So that's just what I wanted to add.
Yep, thanks. And I guess I dropped the link of GitHub of Keras code repository. Folks, do go there, do solve. I guess issues are open. I guess some issues are open, and if you feel any bugs, please raise an issue. I'm also been talking with Anshuman for contributing to Keras, so maybe I will start soon. I'm just going through the docs right now to get better understanding about it. But yeah, I guess yeah. This last thing, I guess Aritra and Ritwik are joining us in person also soon. In you can say in coming 2 weeks. So those who are obviously please join, even though there are very less number of people here. But as if we are recording, if anyone see on our YouTube channel, please register it ASAP. I will be dropping soon tomorrow. Only the registration form open will be tomorrow, and you can check and you can meet up there with us. And it's first time we are doing, because again our chapter is just 3 to 4 months old, if I will say. So like we are trying our best to basically uplift ML community in Chhattisgarh. So please do join us, do support, do share that thing with you all. And I guess we are in the end. Maybe Nishika wants some ending points so she can basically put on. So yeah.
Uh, on the behalf of our whole team, I want to thank our speakers for your presence and guide us all with your experiences. We are really thankful to you, sir. And we also want to thank you all for being so patient and let the event complete successfully. Thank you.
Thank you, everyone.
Thank
Bye.
you.
Thank you, folks. Bye bye. Take care and see you soon in 2 weeks. Yeah. Yeah. Bye bye.
Bye.